Hi, thank you very much for being with us to design a video wall. So normally the first thing that I ask is for you, for the customer, to send us a diagram where you show us the dimensions of the room where the video wall will be and 4 photos. So I am able to see where it is going to be. So in this case, the customer send us the photos and more or less the location looks like this. It is a room that it is 9 meters wide by 9 meters long. So we have here 9 meters and 9 meters. The height is 3 meters. So this is very important because based on this information, we are able to define the size of the video wall that we will recommend. We have seen that many customers want a very big video wall or a very small video wall, and always there's the size that we recommend based on the follow. So really what we started was with a video wall that it is the customer wanted or wants a video wall that is 3x3. So really we are talking that the customer will have a video wall that it is 3x3 monitors. And they wanted 55 inches, the monitors. So we will have here 55 plus 55 plus 55. It will be 165 inches in total. So let's see if this 165 in diagonal inches, it is good. So the first thing it is that the minimum distance that it is 0.8, the distance of 160 inches, that's equal to 165 by 0.8, that 132 inches. This multiplied by 2.54, we will have that the meters we will have 335 centimeters. The recommended distance is 1.6 times the diagonal, 165. That's the recommended, that is equal to 165 by 1.6 is 264 inches. This is the recommended distance, 264 by 2.54, that's equal to 656 centimeters. So that looks fine. And then the maximum distance is 2.6 times 165, that's equal to 2.6 by 165, that's 429 inches. So that's the maximum distance, 429 inches by 2.54, that's 10 meters, 89 centimeters. So we are talking of almost 11 meters. So the length, the depth that we have on this room is 9 meters. So really what I would recommend is to have, let's say here, I will talk in meters. We will have one at 3 meters, one line here at 3 meters, another line at 6 meters, more than 6, I would say 5.5 meters, and then to add another 2.5, that's 5.5 plus 2.5, that's 8 meters. So really we will have here the distance for the operators of this video wall. We will have it at 3 meters, then at 5.5 meters, and then at 8 meters. So if we did this distance, really we will do a very good use of our, we will make a very good use of the video wall. The operators that will be here on this row will see very nice the video wall, the second row and the third row. So the operators will be able to show whatever they need to show from their computer, and they will be able to see it pretty good on this 165 inches video wall that it is a 55. So with that in mind, that's the reason it is very important that you share with me the photos, the diagrams with the dimension of the location, so we are able to define if what you are thinking is the right recommendation. The minimum 132 inches, the optimal 264, and the maximum 429. And based on that, we can accommodate where your people that is going to be using the video wall will be. So this is for a monitor center. So this is very important that we do. So once we have defined this, let's move to the next step. Okay, so the next step will be, we will have 11 operators. So what we will have, it is 11 operators that we want to show. These 11 operators we want to show on the video wall, on the 3x3 video wall. So what we will have is, we will have here the PCs for the 11 operators. So we will have here the 11 operators. So we will have the operator 1 down to the operator 11. So what we define is that we will have 8 operators. I will put here. These are the computers. So what we will have is 8 operators through HDMI and the last 3 through HDVT. So really we will have the video wall processor. We are going to use the brand that we always use is Aseada video wall processor. We will define in few moments what model and the parts that will go. First we will do this. So what we will have, it is the HDMI cable. We will have the HDMI cables coming into the video wall on a maximum distance of 15 meters. So we will have the maximum distance that we will have here is 15 meters. Here it is. And then the other 3 we will use HDVT Cat6. So we will use HDV Cat6 cables because the distance that we will have is longer than the 15 meters that we have defined for the HDMI. So these are distances longer than the 15 meters. And what we will have here from this device, from the computer, we will have a transmitter. We will have a transmitter that will transmit the HDMI up to 90 meters. And this feature on the video wall processor is nice to use it. Normally I recommend to use it. One reason is because we have instances that really to put the HDMI cable, to use the HDMI cable, really it is impossible. Why? Because we need at least of a diameter of 1 inch. So these HDMI cables use a diameter of 1 inch, and really a lot of times it is impossible to put it through the conduits, or the distance is longer than 15 meters. I really don't recommend on distance longer than 50 meters HDMI. So in this case, what we are going to put here, it is the transmitter. What we will have here, it is the transmitter. Of course, this we shared before with the customer. Before we design, we talk to you as a customer, and we define exactly what are the options, and based on the options we show you what are the options, and you choose what's the best option for you based on your environment, and based on that we do the design that you see here. So that's how we found out the information from the customer. It is not, we have already talked to the customer, to the prospect, and he has told, we have tell him the options, and we have come already with this. So the video wall processor will have 8 inputs with HDMI and 3 inputs with HDVT. So really the video wall processor would look like really the input cards that will have the chassis will have 3 cards
On the video wall processor that we use on the SEADA, that's the brand. It is an English, very very good equipment, the SEADA. It is an English brand from England. So we will have 4 ports, an HDMI. I will tell you which one we will use in a few minutes, but we will have 4 inputs for HDMI, 4 inputs for HDMI, and another 4 inputs for HD VST. In a few moments I will put the part numbers there. So that's what we will have. So this will be the inputs. So we have here the input. Then we will have the output. The output, we already talked to the customer, and we will have 9 outputs. We will go to each of the monitors. That it is, of course, you will see them on a 9 by 9, but in this case I will put 1 by 1. We will use a receiver. We will use the receiver. Then we will use the monitor. We use NEC on the monitors that we use. We are married with NEC. I recommend you. I have been married for a long time. And I have learned that it is better to marry one brand. We establish a long-time relationship with them. They see us, they know us, and they are available for us whenever we need. So that's the reason I am married with the SEADA video wall processor, with the NEC. The cables are Axel. I will show it to you as we go. So we have here HD VST. We will have the number 1 monitor all the way to the 9 monitor. We will have the receiver, and then the 9 receiver, the HDMI, and then the NEC. Let me see, put here the NEC professional monitors. Of course, we will put it on a configuration that it is 3 by 3, but how it goes, we will have here the HDMI, and these cables would be just 1 meter. So we have it here, and we have HD VST, Cat6, and we will have 90 meters, the maximum distance. So we will just erase these little dots that we have here. So this way, it is the way that it would look like. This would be the outputs. In this case, we will have 3 slots because we have 9 outputs. Each port, HDVT slot has 4 ports, so we need for 9, we need 4.25. So 2.25 cards. Of course, there's a 0.25 card, so we will need 3 cards for output. So we will put here the output 1, the output 2, and the output 3. So based on this, we will decide if the size of the chassis. In this case, we asked if the customer wanted a power supply, redundant power supply, and he told us that he does not want it. So we are not going to put it on a power supply. On this size of chassis that it is 3 inputs slots and 3 output slots, we are able to put, it has the slot there to put power redundancy there. So now let's put, we use Axel cables. So these are the cables that we use. So this is the configuration. I will make a resume of the configuration. So we will have 8 HDMI inputs, 9 Cat6 HDVT inputs, and the outputs, it will be all the way to the monitors. There would be HDVT outputs, and then there would be the NEC monitors. On the NEC monitors, we have 4 options. One is 1.8 millimeters, that it is 700 candles. The other is 1.8, that is 1.8, 3.5. I will start again. The first is 1.8 millimeters with 700 candles. It is around $5,000 each monitor. So the next one is 1.8 millimeters and 500 candles. The next one is 3.5 millimeters of VCSEL and more or less, and 700 candles, and that's about $4,500 for each monitor. And then the last one is 3.5 millimeters, and the bezel and the candles are 500. So, and it is around, the numbers that I'm giving you are budgetary. It is about $4,000 each monitor. So the one that choose the customer, it is 1.8 millimeters of VCSEL. That's the one that the customer choose. And then 500 candles, the one that is 500 candles of brightness. So this is what the customer choose, and we gave him the options and he decided to go for this. So we will put here what we need and see what are the parts that we need. So stay with me and I will put the part numbers that we will need for this. Very important is that we choose as well for the monitors. We will put the supports for the monitors. We use normally the chief monitors. The chief supports. We have worked with them for a long time and they have never let us down. So we will have 9 of those chief. So we will put here the chief. So each of the monitors must have the support. So we have it here. So we will use 9 of these, the LVS1U. Then we will go for the monitors. We already told you that we are going to use NEC. Normally we use all the same brands. So we bring the expertise in-house. So we have the expertise from the manufacturer and our own expertise with our own engineers. So we are always using the same thing. So practice make masters. So we will use, in this case, it is the monitor UN551VS. So this is the neck that we will use. That's the model UN55VS. So we will use 9 of them. Then we will go on, and the customer told us that they don't want to have any audio, they don't want to have any media player, they don't want to have any wireless presentation. So that's what what I am showing you is what they told us, that they don't want audio. I particularly like a lot to put audio because sometimes on the monitor center there will go people who will go to see what you are doing, and then you need to show off what you are doing there, and then your presentations through video and audio. That's a powerful presentation. But in this case, the customer decided not to do so. So we respect that. We gave him the options and he decided. So we move on. I am finding the cables. One moment, stay with me. But before that, we will go with the video wall processor. I believe that's before. The video wall processor, we will use the SEADA. We will use the 16 inputs and 16 outputs. That means that we can have 4 slots of 4 inputs and 4 slots of 4 outputs. There are others that are different size, but in this case, we will choose the chassis that supports 16 inputs and 16 outputs. This chassis is the SW2000 for you. So we will put that. So this one is able to support 4 input cards. You remember that each card has 4 inputs, and so we will put, so really what we will be able to do, we will be using 3 slots out of the 4 for inputs, and as well for the outputs. On the outputs, we will be using 3 outputs out of the 4 output slots that we have. So hopefully it is understood. We will put there, we say that we don't want the redundancy. I normally recommend to put redundancy. I recommended to the customer, but he didn't want it. So let's be. Then the chassis already comes with the control, the software that controls the video wall. It comes with as well to be able to control through an iPad. So we will be able to control that through an iPad, and as well with the software that is able to control 4 video walls. So in the future, if the customer wants to control it through another, we will be able. So I will here make a little room. We will have here the LAN network. We will have here the LAN network.
and then we will have another computer, or maybe one of these and can be the same. So but we will have I am putting another one just for the case and of this example, but can be any of those. And from here, from this computer, we will install the software, and then we will be able to control that. And as well, we will have the wireless LAN. We will have here the wireless LAN. We will have an iPad. So through the iPad, we will go through Wi-Fi to our wireless LAN, and we will be able to control as well from the Wi-Fi from the iPad. We will be able to control the video wall processor, the SEADA SW2000-4U. So this will be able to do. So we need the already it comes, the softwares already comes with the chassis, so that's what it is. Now we are able to put on the chassis the VGA. I normally don't longer recommend a VGA. I normally recommend HDMI. So we will put the HDMI. So we will put 2 cards. Remember that each card has 4 ports. In this case, it has 4 HDMI ports, so we will have 2. Then we will use the SWIN HDMI 4. 4 means 4 ports. Then we will have the transmitters. We will use 3 transmitters. We can use up to 4 transmitters, but in this case the customer just needs 3 transmitters. The part number for the transmitters are the HBT, HDTX. So we will put 3 of those. Then, so we have already the inputs. The outputs, we will have 1 card for the input. We have these 3 transmitters, so we need, and we will have 1 HDVT capture card. So it is here. So we have 2 cards HDMI for the first 8 computers that come with HDMI, and then the other 3 that comes with HDVT is the SWIN HBT4. So we have it here. Then what else do we have here? So we already did the inputs. Now let's do the outputs. We won't have an HDMI output, so we will have the output. We have 3 cards that are outputs. The HBT4 that is output. So we have 3 cards of outputs. 1, 2, 3, 1, 2, and 3. So we have 3, and then we have 9 receivers. So we have 9 receivers. Here are the 9 receivers. 9 receivers. And then we need the cables. Let's go for the cables. Now we will use the cables. Stay with me. So we will put 15 meters cables. We will put 8. Those are axle. The V162C 050V-43. So those are the ones that we are using. We will need 8. Then we will need a 1 meter. We will need 1 meter, 3 and 9. We will use 12. It is 3 transmitters plus 9 receivers. 3 plus 9, that makes 12. So these cables, the 1 meter cables, are as well from Axel. Is the B116C003V. So that's, we have 12 meters. And that's the cables. So there won't be any audio, as we already mentioned. There won't be any automatization. We will have an iPad. We will have a mini iPad. So this is the video that we will have. We will save it.
So hopefully it is clearly understood. We have 8 inputs HDMI, 3 inputs HDVT. We have here the cards, the 2 HDMI input cards, 1 HDVT input card, 3 HDVT output cards. On the chassis is the SW2004U. We will go through Cat6 to 9 receivers, and then we will have the NC monitors that are 1.8 millimeters of VCSEL and 500 handles, and we will control that through the PC and through the iPad. So we will control the SEADA, the different scenarios that we can make. This SEADA video wall is very nice, does not have power windows, does not have any bugs, so really will stand there for any critical application there for a long time. So let me save it. So we have saved this information on a file, so we have it there. So that's one. The second thing that it is very important is where are we going to install the equipment and the power up. You remember that before we did a diagram where it shows where we will be. You remember that we did this diagram. That's 9 meters deep, the room, by 9 meters wide, by 3 meters high. So where are we going to put the equipment? So let's see, where are we going to put the equipment? So on the room where we will recommend to put it, we will have 3 rows, the row 1, the row 2, and the row 3. There would be, we say, at 3 meters, 5.5 meters, and 8 meters. So we have there, we will have the video wall. We will have the video wall, the 3x3 video wall. So we will have it here on the location. So let's see how much it will measure. So the wide, it is 3.63 meters wide, the video wall.
and the high, it is 204 meters high. Here it is, 2.04 meters high. So we have there. So what we will recommend is that we put the rack here. That's where we will recommend the rack to be here, near the video wall on the left corner, and then the distances we will still design the runs, how we will run from each of the inputs to here to the rack where the processor will be. It is important that we always protect our equipment. I normally like to protect very much our equipment because any turbulence on the energy, on the power supply, will make our investment to cut down. So really, I normally like to put conditioners, power supply conditioners for the equipment, for the monitors, and for the video wall processor. Normally I do that. So here on the rack we will put that. So let me just put here, save this. We'll put here. So what we will do, we will erase this, and what we will do on the rack, we will use a Furman. We will use a Furman PL Plus DMC. We will use 2 to power up the monitors, the neck monitors. So we will have 9. So we will power up the 9 from 1 to 9. We will power up them using the plus. That means that we will have five coming in to the first one. So we will have 4 coming in to the first PL Plus, and then another 5 coming to the second PL Plus, and then we will have a third power conditioner from Furman, the PL Plus, DMC. We will have the third. For the SEADA power supply. You may think it is too much, but you will have a very good night sleep with this. You may not sleep for what's going on your monitor center, but you are going to be sure that you will have always working all the equipment, because these PL Plus DMC power conditioners will save your life, will save the investment and that you have made. The reason number one, because the equipment gets damaged and the life of the equipment gets strongly reduced, is because you don't have a very good power supply coming in. So with this, make sure that you do, and the investment that you are doing, really it is nothing. It is nothing compared to the good dreams that you will have. It is nothing. So you will have here, coming into the AC, to these AC outlets, you will have here your AC outlets. Be sure that they are grounded and that they are good, so we avoid any problems. So have a good electrician to do that. So make sure to put this always in. It gives you a good night sleep every day. So this is the power. So with this in mind, just be sure that it's everything up and running. So we will save this information. So we have already the power. So the last thing is the rack, where we are going to put everything. So we will take this out and we will put a rack where we will put everything. So we will have a rack. You remember the chassis, the one that we said that we were going to have? It has for you. The rack has for you. One moment. So here we have the usage, 1U for each of the PL Plus. So 1U, 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 and then we will have 4U for the video wall processor. So the total use that we need are 7 use. That's the total. So we will use a rack that has 9 views. So I will show you the one that we are going to use. The rack has 9 views. So we will use one from North system. The part number is North 016 PK. So we will have the North system, the North 0 that has, this one has 9U. 9U. So with this is more than enough. This would be the rack. Okay, so that's what it is. So we have done the video, we didn't do the audio, we didn't do the automatization because it is not needed. We did the alimentation, the power, and then we did the rack. So we will do a little resume of what we have gone through, so you remember how we can help you. The first thing, the dimensions. It is very important that we calculate the dimensions. Remember that we have here 165 diagonal inches, so the minimum distance recommended is 0.8. The recommended distance is 1.6, and the maximum distance is 2.6 times the diagonal. So based on that, we define that we will put the people at 3 meters, at 5.5 meters, and at 8 meters. So all the operators have a good view from the video wall. So that's very important. Then we will have the video. We have the video. We have 11 operators. Out of those would be 8 that would be with HDMI, and 3 would be with HDVT. Because the distance is longer, we will use the HDMI cables. We will have the inputs, 3 cards inputs, 2 HDMI and 1 HDVT. And the outputs, we will have 3 outputs. On the outputs, there would be 9 HDVT, and then we will have the receivers. We will use the monitors, the NEC, that have 1.8 millimeters and 500 candles. And we will be able to control from a PC. Can be the same that we are using here, but we put different PC from the PC or from the iPad. And we will be able to control the video wall processor. We will make different scenarios. So we will see whatever input that we have here, we will see it on all the monitors, and we will be plenty of windows to share. You can create the scenarios, you can do it manually. You will define whatever you want to see, wherever you want to see it, on any location that you want to see it on your video wall. Then the power, this will save your dreams. Remember, put a Furman PL Plus DMC. I always go to sleep because I put on all my installations this. The investment that you do is nothing compared to the good night sleeps that you will have. So you power up, and then the last thing is the rack. So we put the rack just to put on a nice location all your equipment, the 3 Plus and the SEADA, and then you go to the transmitters and then to the receivers that we'll have. So with this in mind, that's it. I do thank you for being with us. My name is Arturo Mendoza Larios. You can send me an email to Arturo, ARTURO, at tdm.com.mx. You can go to my Skype, arturo.tdm.com.mx, ARTURO.T as in Tom, D as in Dave, M as in Mike.com.mx. You can go there to our webpage, www.tdm.com.mx. So I invite you to subscribe to our channel, to our Facebook, to our LinkedIn, to our all social network. And the way that we like to work with you, you send us the photos, the dimensions of the room. We talk to you through a video conference. We define exactly what you have. We talk openly about investment and everything. And based on that, we present a solution. Like on this case, from the budgetary point of view, the investment of all this, it is $120,000. So the investment that you will have is about $120,000. So for all this implemented anywhere in the world. So I invite you to come. We have the knowledge, expertise, and wisdom to help you design and implement the video that you need as per your needs. Thank you very much for being with us. Have a great day.